So welcome everybody to this latest GCSE video on 162 Maths, and in this video we'll be going through some of the common and typical indices questions you can find on both the foundation and the higher exam. So in this video we're going to go through a mixture of foundation and higher GCSE indices questions. Now they do go quite intense near the end, so if you are doing either starting GCSEs or you're doing your foundation GCSE, you may only encounter some of the earlier questions. So if the latter questions don't make sense, particularly ones that combine indices with surds, then like I said, do not worry. And like I said, if you want to have a go at these questions, which I recommend that you do before watching this video, because all I'm going to do here is just go through the answers to the questions on the documents that are attached in the description below. So let's have a look at these multiple choice questions now. So these questions are taken at level 5, so the level 5 questions could easily appear on the foundation paper, and anything beyond that could appear on the higher paper. So in this first one, all it's a case of doing is using the sort of first law of indices. So when we're multiplying and the bases are the same, what do we do to the powers? Well, we add them. So that's going to be x plus 2 plus 8, which is x to the power of 10. So looking at B here, we're dividing. So let's just go to that little cursor. So here we are dividing, and the base is the same. So we're going to do a of 2 minus 8. 2 take away 8 is minus 6. So there is our option there. And then when we've got brackets, what do you do to the powers? We multiply them. So that's going to be y 2 times 8. And that's going to be 16. Where are you? There you are. And so we just circle that one. For question 2, it's saying simplify the following expression. So here we've got 4x to the power of minus 2. Now here what we've got to do is we need to deal with the minus and then deal with the power. So from this, dealing with the minus, that's going to be 1 over, and then we've got 4x squared. And then remembering here what we need to do is square both the number and the letter. So it's going to be 1 over, 4 squared is going to be 16, and x squared is x squared. And there is our final answer. For question 2b, we want to simplify, and let's get rid of this cursor, 8, and we've got fractional power. So we've got 8, and it's to the power of 2 cube rooted. So here 8 squared is 64, so I'll do the cube root of 64, which is 4. Alternatively, what I could have done is done the cube root of 8, which is 2, and then squared it, and I would have got the same answer of 4. For question 2c, again with a fractional power here, so again I do exactly the same. So it's going to be 1 over 4 to the power of 3 over 2, which therefore is going to be 1 over 4 to the power of 3 square rooted. Now 4 cubed is 64, so that's going to be equal to 1 over the square root of 64, and 1 over 64 is an eighth. Well, 1 over 64, root 64 is going to be an eighth rather. Now moving on to question 2d. Now for this one, what we need to do is square root both of these two things here. Now here, 81 to the power of a half is just the square root of 81, which is 9. And 2 to the power of 4 is 2 times 2 times 2 times 2, which is 16. So what I've then got is the square root of 9 times square root of 16. Now if you think of surds, if those you're doing higher, foundation may not have a clue, but you can either then work that out, but what I can do is split this up is square root of 9 times the square root of 16, which is 3 times 4, which gives me a final answer of 12. Now if I did do 9 times 16, you should work out that that's going to give you 144, and the square root of 144 is 12. So if you're doing foundation, that's probably the way that you probably work through it, whereas if you know your rules of surds and you've been taught it, then you could get the answer that way as well. So let's have a look at question 3. So question 3 is involving 2 steps. So what I need to do is simplify the top and then deal with the bottom. So here I'm multiplying, so we've got to add the powers. So 2 plus minus 4 is minus 2, because the symbols in the middle become a minus, it becomes minus 2, so that's 5 to the power of minus 2 over 5 cubed. Now that is the same as dividing, and when I'm dividing, what do I do to the powers? I take it away, so I've got minus 2 minus 3, which gives me minus 5, so the final answer is 5 to the power of minus 5. Then moving on to our next question, question 4. Now this is involving algebraic manipulation. So again, I'm going to have to deal with the top and the bottom separately. Now for 2 marks, I would say this is pretty stingy, but it is what it is. So in terms of this, what I do is neaten the top. So multiplying out this top line, I get 5 times 2, which is 10. And then I've got x squared times x to the power 4. So I add the powers, so that becomes x to the power of 6. And I add the powers of y, so 3 plus minus 2 just gives me y, or y1. And that's all over 10x6y. So from this, I can notice that I've got both the same on the top and on the bottom. So that's just going to equal 1. Then moving over to question 5. Now question 5 is asking me to write the following expression as a power of 5. Now sometimes you may get these questions. So what I need to do first is I need to change the 25 as a power of 5. So what I'm going to do is, rather than writing 25, instead I'm going to write 5 squared to the power of 5, because there's a 5 there, and that's over 5 cubed. Now again, working with the rules, when I've got brackets, I times the powers, so that's 5 to the power of 10 over 5 cubed, which then take away the powers, gives me an answer of 5 to the power of 7. And moving on to question 6, what we've got is we've got 27 to the power of 2/3. So that's going to be 27 to squared over the cube root. So you just got to ask yourself, is it easier to cube root 27 or square 27? Well, it's easier to cube root 27 because 27 is a cube number. So getting rid of that cube root 27 is 3, so that becomes 3 squared, and 3 squared gives us an answer of 9. Now when it comes to question 6b, again, it's recognizing what this actually means. So here we've got 32 to the power of 3 over 5. Now here we've got, if we just translate what that means, it's 32 cubed to the root of, to the 5th root. Now when it comes to quite a large root, it tends to be, the number is going to be a power of, or a sort of a number of 2. So here we just need to see how many 2's and hope that it's 5 goes into 32 when we reverse the root. So here we've got 2 times 2, which is 4, 8, 16 and 32. So here the 5th root of 32 is going to equal 2. So from this, if we deal with this bit first, that is going to equal 2. So then all I've then got to do is do the cube root of 2, which is 8. Then looking at the next one, so here we've got 64 to the power of 3 over 2. So I've got 64 cubed square rooted. Now here what I want to do is think to myself, do I cube the 64, can I square it? Well, squaring is going to be the best option. So I do this bit first. So here what I've got is the square root of 64 is 8. So then I just need to work out what 8 cubed is. Now 8 cubed is not one of those numbers that you kind of need to know off the top of your head, but you need to know what it actually means. Well, 8 squared is what's 8 times 8 times 8. 8 times 8 is 64. So what I need to do is work out what 64 times 8 is. If I do 64 times 8, whichever way you prefer it, or using the grid method, we should get the answer of 512. Now moving on to question 7, it's asking me to express the cube root of y in the form of y to the power of k. So basically what this is doing is asking me to write this in indice form. So how do I cube root something without actually cube rooting it in the form of a power? Well, that's going to be writing it as a power of a third. 7b is then asking me, notice how now we're getting into higher. So for this, it's asking me to express 1 over y times the square root of y in the form of y to the power of k. Now, obviously, because I've got 1 over, means that I'm going to end up with a minus k. So let me just write that first. So y to the power of minus k is going to equal y lots of root y. Now what is root y? Well, that's the same as y times the square root of y. Another way of writing square root of y is, I've put another equal sign, so let's get rid of that, is to write y to the power of a half, and then that's to the power of 1, so then I'm multiplying, so I add the powers, so that's y to the power of 1 plus a half, which is 3 over 2. So y equals, so in terms of this, y equals minus 3 over 2, and there is my final answer. Then looking at question 7c, show that 2 1/4 is equal to 1.5. Well, here what we want to do is write 2 1/4 as a improper fraction. So here what do? Well, I do the big number times by the bottom, add to the top, gives me 9/4. And now again, all I want to do is square root these two numbers. So because it's higher, we'll be expected to know that this is going to be a thirds question as well. So the square root of 9 is 3, square root of 4 is 2, so then the final answer is 3/2, which equals 1.5. So therefore I've showed what it's asked me to show. And so now let's have a look at another set of exam high GCSE questions. Again, this is worth 3 marks. So what we need to do is deal with these separately. So dealing with this, 3 to the power of 12 divided by 3 to the power of 5. So here I'm going to take away the powers. So that's going to be 3 to the power of 7 divided by, and then work out what this bracket is. And again, if there's no power, imagine there's a 1. So again, I'm going to add the powers. So that's 3 to the power of 3. And then from this, I'm dividing, so I take away the powers. So that's going to be 3 to the power of 4 as my final answer. Now, if I did write the answer of 81, that should give me full marks because it's not asked me how it wants me to write the answer. So whether I write it in index form or I write it as a value, that should be okay. Now, in terms of question 2, again, it's asking me to work out the value of a. Now, in terms of the left-hand side, I've got the square root of 6 squared plus 8 squared. Now, if I just work that out, that's going to give me the square root of 36 plus 64, which added together gives me the square root of 100, which equals 10. Now, if I look at the right-hand side, which I'll do in a different colour, what I want to do is I've got the cube root of 125a cubed. Now here I can treat this as separately because it's like using surds. I can cube root 125 and I can multiply that by the cube root of a cubed. Now here the cube root of 125 we should know is equaling 5. And the cube root of a cubed, well, that cube root cancels with that cube, so it just becomes a. So what does that then become is 5a. Now, if 10 equals 5a, what times 5 gives me 10? Well, a is therefore going to equal 2. Now, looking at question 3, again, it's asking me just to convert this. So again, it's going to be 1 over 3 squared, which is 1 over 9, which is that option there. Now for question B, these questions are very common, so it's just a case of working these bits out separately. So minus 8 to the power of 0, well, anything to the power of 0 is 1. And then I've got to work with this 8 to the power of minus 2/3. So 8 to the power of minus 2/3, well, dealing with the minus, that becomes 1 over 8 to the power of 2/3. That then becomes 1 over, now it's going to be 8 squared cube rooted. And this will give us 1 over 4. So then going back to the original question, so if this is a quarter, all I then need to do is add those two numbers together, in which what I'm going to get is 1 1/4. Or if I want to write it as a mixed number, it's going to be 5 over 4. Looking at our next question, so question 4, it says if a equals 7, b equals 2, work out the value of this. Well, it's just simply substituting numbers in. I get 7 over 2 minus 7 to the power of 2. And again, so that's going to be 3.5 minus 49. So then all I've got to do is just simply work that out. 3.5 take away, which is going to give me a minus number, and that's going to give me 45.5 as my final answer. Now for question 5, again, well, we've already done this type of question, so this is going to be 1 over 8 to the power of 2/3, which is 1 over the cube root of 8 squared, which is 1 over, and again, depending on which one you want to do, it's going to be the cube root of 64, which is going to give you an answer of 1 over 4. Then for question 6, it's asking me to estimate. So here, estimating, all we need to do is make these numbers as close as possible to one significant figure. So this estimated is going to be, rather than using 101.4, I'm going to use 100. Rather than using 6.43, I'm going to use 6. And rather than using 7.99, I'm going to use 8. So simplifying this, what do I get? well, the square root of that's the square root of 100 plus anything to the power of 1 is just 1 times. Now 8 to the power of 2/3, which again is equal to 8 cubed, and so 8, not cubed, squared rather, cube rooted, which is the cube root of 64, which is just 4. So then that's going to be equal to 4. And then working this out, I get 10 plus 4 times 1, which is 4. So 10 plus 4 is going to give me an answer of 14. And then with question 7. And now what I want to do here is when you have a mixture of base numbers, what we want to try and do is convert this into ones. Now what I should spot is that 8 and 32 can be written as powers of 2. So 8 is equal to 2 cubed and 32 is equal to 2 to the power of 5. Now from this, what I'm going to do is if I just simply swap these with what I've highlighted in yellow, then what I end up with is 2 cubed in brackets to the power of 4 divided by 2 to the power of 5 2 over 5 in brackets. Now multiplying out the brackets, what do I get? Well, I get 2 to the power of 12 divided by, and 5 times 2/5 becomes 2. It should be, not 5. Don't know why I've written 5 there. And then taking away the powers, that leaves me with 2 to the power of 10. And then looking at our last question, which again, very, very similar. So what we need to do here is simplify that left-hand side. So here we've got 2 to the power of, so taking this left-hand side, I've got 2 to the power of 3x divided by 2 to the power of x minus 5. Now when we are dividing, we take away the powers. So what I've got is I've got 3x minus, and then x minus 5. Which then becomes 3x minus x plus 5, which then becomes 2x plus 5. And that is all equal to this power, which is 17. So then all I then need to do is solve this, so take away the 5, so that becomes 2x equals 12, and then solve that for x, which is 6, so x equals 6.